class we have started classification of system, in which we have studied about static and dynamic system, and then we have covered causal and non-causal system, and how to verify a system is a causal and how to verify a system is a static or dynamic system. Then in this class we will study about linear and non-linear system, which we have already studied in with respect to the subject circuit theory. That is the circuit theory. We all have studied about this linearity, non-linearity concept. That we will study in this lecture. So, how to verify whether a system is a linear system and non-linear system, and what is the definition of a system to is said to be a linear system, that we will see. So, a system is system that satisfies the superposition principle is said to be linear system. So we know all might have solved many problems on this superposition principle in a subject called your circuit theory. So where we have, for example, two or more sources are present, then and you want to find the current and voltage across a load. Then in that case, individually you are short circuit or open circuit the other sources and considering only one sources, and finally add all the response of each sources. That we will see here also the same principle but in a different way. So a system is said to be a linear system if it satisfies the superposition principle. So what is this superposition principle? So superposition principle states that the response of the system, the response means output. Always remember, response means output of the system. Excitation means input of the system. So the response of the system to a weighted sum of signals. What is this weighted sum of signal? We will see. Weighted sum of signal. That means we are going to apply two or more signals to the system, and whatever output we will get, that must be equal to the corresponding weighted sum of the outputs of the system to each of the individual signals. ठीक है, अगर हम एट ए टाइम अगर मान लीजिए कि 3-4 सोर्सेस है और एट ए टाइम सारे सोर्सेस को अप्लाई कर रहे हैं और करंट निकाल रहे हैं कि ये करंट और वोल्टेज अक्रॉस द लोड हम फाइंड कर रहे हैं, करंट थ्रू द लोड और वोल्टेज अक्रॉस द लोड, देन ऑब्वियसली व्हाट इज द रिजल्ट वी विल गेट इफ वी कंसीडर ईच सोर्स individually, then also the sum of the individual response must be equal to that weighted sum. So mathematically, when I solve one question, one or more few examples when I solve, then we will have clear concept about this, how to apply the superposition principle. So always remember, a system is said to be a linear system only when it satisfies superposition principle. And what is the superposition principle, which I have written here? It says that the response of the system to a weighted sum of signals, to a weighted, this is very important, to a weighted sum of signals should be equal to the corresponding weighted sum of the outputs of the system to each of the individual signal, to each of the individual signal. अगर 4-5 सोर्स है उसके थ्रू अगर हम अप्लाई कर रहे हैं एट ए टाइम, जो रिजल्ट आएगा तो इंडिविजुअली अगर हम अप्लाई करेंगे कैलकुलेट करने के लिए करंट और वोल्टेज और रेस्पॉन्स ऑफ द सिस्टम, दैट सम मस्ट बी इक्वल टू दैट वेटेड सम. ठीक है, तो अभी हम सॉल्व करेंगे क्वेश्चन. पहले हम देखते हैं कि मैथमेटिकली हाउ टू राइट दिस स्टेटमेंट मैथमेटिकली, देन वी विल सॉल्व फ्यू एग्जांपल्स अभी टू वेरीफाई वेदर ए सिस्टम इज linear system or a non-linear system. So obviously if the system doesn't satisfy superposition principle, then we state it otherwise as a non-linear system. In circuit theory you might have said Ohm's law is valid only to a linear system. So all the elements, that is resistance, capacitance, inductance, they are all linear elements, but your diode, transistor, they are all non-linear elements. But in this case we will solve how to verify whether the system in a discrete time system, whether a system is a linear system or a non-linear system, that we will see. So mathematically how to write this? This is the expression, sum of the weighted samples. You can see here, this is the response. That is, here T denotes the function, because the output is a function of these two weighted sum of signal. Output is a function of these two weighted sum of signal. Weighted, why weighted is A1 and A2 are the coefficient, and that is the weight of the signal. We can write here as 2x1n plus 3x2n, like that. So A and A2 are the arbitrary constant, and when we are applying both the signals at a time to the system, the response that we will get, that must be equal to, here we can see individual sum of the individual response. Here this is the weighted sum of signals that we are at a time applying to the system, that is x1 and x2n. We can apply up to x3, x4, as many signals as you want. Here I am considering only two signals, one is x1n and x2n, and combinedly I am applying to the system. The sum, the response that we will get, that must be equal to the individual sum of the response of the signal. That is, when we apply only x1n, the response we will get must be, and only x2n, the response we will get, that must be added, and whatever response we will get individually must be equal to the sum of the response. Just imagine a voltage source and a current source. Suppose this is the voltage source and current source, and we are applying just like this. I am going to explain you with respect to a circuit. Suppose you want to find the current through this resistance. So if I apply these two sources, that means x1, here this voltage source is the x1, 3 volts, suppose this voltage source is x1 and this current source is x2. So whatever current we will get by applying these two signal must be equal to when I apply only one. In superposition, what you will do? When you apply single source, that is 3 volt, then you open circuit this 2 ampere, and then when you apply this 2 ampere current, then you short circuit this. Obviously this is wait a minute, just add one more resistance here. Suppose this is 2 ohm and this is, for example, 5. And now you can see here, when you apply superposition principle, what you will do? First you will short circuit, for example, when you consider this 3 volt source and you get the response here. For this 3 volt source you get the response, that is suppose x1n, and then you consider this 2 ampere source and short circuit this, and you get the response across this 4 ohm, that is your x2n. And individual sum must be equal to when you consider all these two sources at a time. That you will do in your circuit theory. This is just like that. So where A1 and A2 are the constant. So when you apply both the signals, the response you will get must be equal to the individual responses. So let us verify how to verify whether a system is linear. If it satisfies this condition, then it is a linear system. Otherwise, we can say that is, if it doesn't obey the superposition principle or this mathematical equation that is based on your superposition principle, then the system is known as your non-linear system. So let us solve one problem to verify whether the system is a linear system or not. Question is verify whether the system is linear system or not. Verify whether the system is a linear system or not. And the question is, the first question is, suppose you have the response of the system. This is the equation they given, n x n. xn. So yn is equal to n xn. So you always know yn is your response, xn is the input. So when you apply xn as an input to the system, you get the response as n of xn. So now you want to verify whether this system is a linear system or a non-linear system. And how to verify? First of all, we have to apply So you can see here. So when I apply the system with the weighted sum of, suppose I consider here x1n, just to verify whether the system is linear or non-linear system, whether the system is a linear or non-linear system. So we got the response and excitation equation, that is your yn is equal to n xn. So when you apply a1 x1n, we got the response as y1n, and that is nothing but the response means here this is function of y1n is a function of t a1 x1n, which is nothing but how to replace n. Just in place of xn we have to write a1 x1n, because when you apply xn the response is n xn. So when you apply a1 x1n the response will be n a1 x1n. Similarly when you apply a2 x2n the response will be n a2 x2n. So this is how, that is here I am applying individual signal. So now you can see here. So now we have to take the sum. So how to write the sum? So individually we are applying two signals, that is x1n and x2n, and we are getting the result. So the weighted sum of the output is so a1 is a constant, so I have to keep it as outside. So t x1n plus a2t x2n, which is nothing but, so how do we get, in place of t x1n we will get, what is the response, that is so how do we play this, because the system equals is n. So a1n x1n plus a2n x2n. So this is the weighted sum of response. So individually I have considered, then I add, just first I consider x1n and x2n, and now after adding we get the result. So this is the weighted sum of individual response. Now I have to consider at a time when I apply both the signals. That I have to write here. So when I apply simultaneously both the signals in the system, and suppose this is your equation 1. This is the weighted sum of the output. So when I apply both the signals as a1 x1n plus a2 x2n simultaneously to this system, then also I got the same result, that is yn is equal to n of a1 x1n plus n of a2 x2. This is your equation 2. So now we can verify equation 1 must be equal to equation 2. Hence equation 1 is equal to equation 2. So this system is a linear system. So obviously when we apply weighted sum of at a time, First of all, you consider the individual response, and after getting the individual response, you just add, and this is equation 1. And now you can see when I apply weighted sum of input to the system, and I also get the equation 2, and this equation 1 and equation 2 are equal. Hence, it is proved that this is a linear system. So now one more question. Same question, verify whether the system is a linear and non-linear system. And the question is yn is equal to x square x. Yn is equal to x square n, and verify whether the system is a linear system or not. So moment you see what you can inference from this equation. So what type of system it is? It is a squaring system. So the system will be like this. So this is a squaring system. So whatever we are applying input as xn, but we are getting the response yn as square. So obviously this is a square system. So you all have studied about this squaring system in your communication, square law, modulator, etc. So xn we are applying and we are getting the response as x square. So obviously this is a square system. So then we have to verify whether the square system is a linear system or non-linear system. So first we have to consider individual response. So how to see individual response? So this is x square. This is a system, and this is because whatever I am applying, suppose I am applying a x1n. So a x1n. So when I apply xn, we are getting x square n. So when I apply a1 x1n, so obviously we will get response y1 is equal to a1 square x1 square. Okay. So when I apply xn, we get x square n. So when I apply a1 x1n, so obviously the system will square that. So square means we will get a1 square x1 square n. So again when you apply same system with a different signal, that is a2 x2n, then obviously we will get y2 as a2 square x2 square. You will get a2 square x2 square n. So now we have to add both the response. So by the weighted sum of this signal, the weighted sorry, I have to write click. So the weighted sum of output, that means we have to add this to the weighted sum of output, because I am first applying individual signal and getting the response. Now I have to add this to the weighted sum of output is, what is the output will be? So output will be yn, is nothing but y1n plus y2n, and we have seen, so we have seen y1n value is a1 square x1 square n plus a2 square x2 square n. a2 square n. This is equation number 1. So this is the weighted sum of output. So now I have to apply both these two signals simultaneously to the system, and what will be the result? If that must be equal to equation 1, then only the system is a linear system. Otherwise it is a non-linear system. So now I am applying the same system with weighted sum of output, that is a1 x1 n plus a2 x2 n. So we will get, here we will get yn as, so So obviously what it will do, it will square this whole. So we will get a1 x1n plus a2 x2n whole square. So now we can see this is a plus b. Suppose a plus b whole square. That means obviously we will get a square plus b square plus 2ab. So if we open this, we get a1 square x1 square n plus a2 square x2 square n plus 2a1 a2 x1n into x2n. So now this is equation number 2. So from this we can verify this equation 1 and equation 2 are not equal. Here we will get a1 square x1 square n plus a2 square x2 square n, and there we will get a1 square x1 square n plus a2 square x2 square n, and additional term, that is 2a1 a2 x1 n x2 n. And we can see here this equation 1 not equal to equation 2. Hence obviously this system is a non-linear system. This is a non-linear system. So few homework question I will give you. So kindly solve. Then you will have command. First you have to apply individually and add the result. That will be the equation number 1. Then you have to apply both the signals simultaneously. And if that response equal to the individual weighted sum of response, then the system will be a linear system. So check whether the homework question will check whether the system is linear or non-linear. Check whether the following system is linear or so by comparing the input and output, we are verifying what the system. So you don't know about the system. They will provide you the output and input relation, and from that relation we have to verify whether the system is a linear or non-linear. So first question will be yn is equal to n x square n. The second one will be yn is equal to 1 by x of n. So these two systems you have to verify whether the system is a. Then another question, yn is equal to, this is 1 by xn, yn is equal to xn plus some constant 3. So we have to check whether these systems are linear or non-linear. If at all any doubt arises, we will discuss it with the doubt clear class. So thank you. In the next class we will study about time invariant and variant, that is most important concept. Then we have FIR and IR system. So after that we will see convolution. So that will be the end of your module. So thank you.